Coursework.
Also, good.
The pengajian arm need to do it very mandatory.
Pengajian arm is general paper lah.
Yeah, but the coursework very important to do.
Yeah, I know. Ours one, you have to pass it lah as what's the requirement to get a full certificate. So how is your thesis getting on?
Slowly lah. I mean, not that great, but slowly lah.
So your result should be out soon now. In SPM is out.
Yeah, SPM next week, Thursday, for my sister.
Oh, your sister has SPM already, ah?
Yeah, she unfortunately she sat down this year only, ma.
Okay, SPM this year, okay. Okay, next Friday, your test, okay, no, Friday 4 to 5.
4 to 5.
4 to 5. Then Saturday another hour, lor.
Now what's that focus on STPM there?
Focus is for you to do, you discuss some, and then the others are for you to do structure and essay. We'll discuss that the next lesson.
Okay.
Okay, got all that in? Okay, let's start then. If you got all that in. I just finished our potential divider.
Yeah.
Last part only. Wheatstone bridge. Wheatstone bridge. Right, there's your potential divider. You refer to your note. There's your R1, there's your R2, there's your V. We can draw it this way. In electronic, we instead of drawing a battery, we are just lazy. We just put as this the ground, and there's a V, that's all. It's the same idea. There's a current, there's a R1, there's a R2. So you need to know that V, that battery doesn't have any internal resistance. So that V is just V1 plus V2. And then V1 over the whole V is R1 plus R2. It's just a ratio, that's all, because the current is the same. Or same current, V1 divided by V2 is R1 over R2, which you can show. It's just IR2, IR1. The I will cancel off. Okay, so that is how the Wheatstone bridge circuit will look like. You got a cell there, you got 4 resistors. Right? Between them, there's a galvanometer. Sorry, this is your symbol. Right? Some people write a symbol, galvanometer or voltmeter. This is standard resistor, P and Q. Standard means it has a fixed value, not like the carbon resistor. It's a coil resistor. So this one form a ratio arm. Ratio arm. That means P divided by Q will give you a number, a ratio. S is a variable resistor. R and S form the other ratio arm. Right? This one divided by that, this one divided by that. That's why I made my ratio arm. Basically, we want to find this unknown resistance R. Right? This 2 is chosen, give a ratio, and we adjust this one until there's no current flowing through here. So RS, PQ are potential divider. These are potential divider one side. This is a potential divider the other side. And voltmeter is just to show that there's no potential difference between P and Q. That's all. It shows 0 voltage, means no potential difference between donkey and your B, or B and T are at the same potential. Or we can use
so voltmeter means usually just to show that potential difference zero only lah. The V is zero only.
just to measure potential difference. So if there's no
Oh,
potential difference, means there's no current. So you can use a center zero galvanometer to show that there's no current.
okay.
Same thing, either a
Where's
voltmeter,
the galvanometer located?
galvanometer measure current. It also show the same thing, that the potential between
In
V
the
and
diagram
P
where the galvanometer is located.
to measure current, small current. So it's just to show the potential between B and D is zero. Then no current flow. So you can use a voltmeter or galvanometer.
The center zero galvanometer.
Yep, because the current, when you adjust S, you don't know where the current will go. It can go left or can go right. Okay, so this is just to express you. This side is one side, potential divider. This the other side, the potential divider. And then when that is zero, so resistance of S is the resistance. It's adjusted until the pointer, it can be galvanometer, it can be voltmeter, points to zero, no current or no potential difference. So when the galvanometer reaches zero, no current flows through these 2 points, B and D, right? These 2 points. So all the current there, the current coming from the battery will split into I1 going here, I2 going here. Right? So either there's no current between B and D, or there's no potential difference between B and D. Both are at the same potential.
So what about A and C? A to C, yeah, A and C.
You see, we are not worried about A to C, or there's no connection now. Why you worry about A and C? There's no connection.
Oh,
There's a current flow only there. Flow here, flow there. Same here. Flow here, flow there. So focus on where the current flow. So I1 flows to R and S. I2 flows to P and Q. Same, the two pictures are the same, it's just differently drawn, that's all. You just flatten this part, that's all. So we can say that your potential, this one, across VAD, this one, is the same as the
equivalent.
potential across this one, VAB.
Mm.
Then we can replace I1 times R, I2 times
Because
P.
D to B is zero, that's why it's equal lah.
Because that part is zero, from D to P is zero. No current flow through that.
Yeah,
Right? So the
that's why they are
potential is the
equal.
same. Potential, we say that D and B is the same potential because no current flow through that. That's why the potential is the same. Here, cross R and across P, that's what this is saying. And the same thing, potential across this one is the same as the potential across this one.
Yep.
And the current is the same, I1 times S, I2 times Q. Second equation, and then we just divide them. Right? 1 divided by 2, R divided by S, I1 and I1 cancel off, and I2P divided by I2Q, cancel the I1 and I2, you get your, take the S across there, we got PQ over S. Okay, so the main thing to remember is this ratio, P over S, sorry, R over S is P over Q, the two ratio arm. That's how it looks like. Right? Either you draw it this way or you can see that way there. Let's look at some of the thing there. Right? It's a uniform wire. Right? There's a meter rule there. Uniform wire is on that. There's your jockey. Right? It's here. Same thing here. Sorry.
What's a
Here.
jockey?
It's just a sliding contact, that's all.
Oh.
Right? Just a pointer. And there's your power supply or battery, which is here. There's your switch. It's your switch. Right? It's your uniform wire there. Right? Power supply is a need to provide energy, that's all. The current to flow. And that is R This is also for R. And then this is S. You can use a resistance box. It has a fixed resistance to allow us to change resistance and can read the value on the resistance box. Okay, so S is a standard resistor or resistance box. Okay, it's just to show you the relationship, the same thing. Right? There's your battery. There's your R. There's your S. There's your R. There's your S. Instead of P and Q, we have a length of wire. Right? Length of wire, AC. Uniform wire of length 1 meter is used to replace P and that one, P and Q. R is the unknown resistor. That's your R. One there. S is the standard resistor. This one, which is allowed to change, or resistance box. G is your center zero galvanometer connected in series with a sliding contact. So there's a sliding contact. It's just like a pen that's all made of metal. So galvanometer is just to show null deflection, null detector. That means it must be able to deflect on either side to show that there's no current flowing rather than zero current. Because zero current can mean that your switch is not on. Right? So the galvanometer null deflector, it shows zero, it can deflect to the left or to the right, then you can adjust it to zero by
So
slide.
which means galvanometer is actually useless lah. That means in a way.
It's not useless.
Right?
It's not useless. It indicates to you where is the point where there's no current. It's not to
Okay.
it's not there to detect zero only. Zero can mean the switch is off. But this is a null detector. Detect zero. That means it can either go to left or right and adjust until the current is zero. Right? And that cell doesn't do anything, just to provide energy, that's all, for the current to flow. Connected across AC. Okay, any comment?
No.
Okay, let's carry on then.
Che, AC connector in series only, parallel
Like
can
this one only. This is only series, or in a straight line,
but parallel cannot lah.
you know, because you want the current to flow through galvanometer, right? Current is detected from the point B and point D. There is a potential difference between D and B, so the current will flow through. If there's no potential difference, there's no current that flow through. Right? So the sliding contact is moved along the wire until the galvanometer shows zero deflection. So when the meter bridge is balanced, resistance of wire is proportional to length of the wire. Provide the cross-sectional area is uniform. Right? The key is a uniform wire, this one. Then we can use R over S is P, this is your P, this is your Q. Right? And then since our resistance is proportional to length, then you can write as L1 over L2. Right? L2 can be, if you measure in cm, then L2 100 minus L1, no? Right? Depend on which one you prefer to memorize. So. Right? Then R is S, L1 over L2. What are some of the things you have to be careful about, precaution, when you use this instrument? Right? You want to choose your balance point B between 35 to 65 cm. This is to ensure more accurate by reducing the percentage error in L1 and L2. That's what it means. Right? That is my symbol for percentage error in R, delta R over R times 100%. So there's percentage error in R, that one. Percentage error in S, percentage error in L2, L1, this one, percentage error in L2. So if the L2 is large, somewhere between there is good enough, right? Not too small. Same with L1. If L2 is 35, then L1 is 65, so it's okay. Then this one will be very small. That's the whole idea. Okay. In everything, we try to keep.
Sure, just one question. You know the delta L2 over L2, right? Like others all don't have over. This one only Hong Kong got over all.
Say again.
That down equation there, right? Below the delta R thing, right? The combined equation. Delta L2 over L2 part, like the others one don't have over. Only
The others, the
this one
same
only have
thing. That's why I show you here. Rather than write the whole thing, I just show you this is the symbol for delta R about 100%. So that's why I don't want to write it down there. Right? Same like this one.
Oh,
Delta S over S times 100%. This delta L1 over L2 times 100%. Same thing. That's the reason for all that.
delta L1 over L1 times 100%.
Delta L1 over L1 times 100%. That's my short form.
Oh, you didn't want to write everything,
Yeah.
lah. That means.
You just have to write very fast when you want to take note.
Oh, okay.
Yes, sir. You have to learn to accept short form. But exam, of course, you cannot write like that. Lah. Exam, you have to write fully.
Which means delta S over S times 100, like fully lah.
Yes, you have to write fully. You cannot write short form. Short form is because when you go to university, depend on how kind is the lecturer. Sometimes they will just talk and then you have to write down. So if you can write short form, you can take the note down faster. I don't know about your time. My time, that's why we have a struggle with. Lecture not like us now. Give you all the notes, everything, pamper you. Now may change, I don't know. Lah. Right? Remember that AC is a uniform wire. So do not slide. It means I do not, this is my pointer, like this pointer. It's your sliding contact. I don't slide along here like that. Right? When I want to measure, I put it there. After that, take it up, put it there, take it up and put it there. Until it's zero. Don't slide. What happens when you slide? When you slide, you scrape metal. So you remove the uniformity. Right? Why normal uniform already? So the equation doesn't work anymore. Then after that, you interchange R and S and measure R again. Why? To correct for an error here. This error here and then this error here. Right? Because it may not have been joined properly. So it may not be, maybe just close to 1 meter but slightly less. Right? That can be some of the reason, or slightly more than 1 meter. We assume that this is 1 meter. So by interchanging these two and find L1 and L2 again, finding L1 and L2 again allow us to find the average of R. Okay, so that is all the formulas that you need to know for this topic. Okay, let's try one question. Okay, try this one. What's the answer? Can get the answer? Remember AC is 100 cm.
Oh, okay. Oh yeah, 1 meter, right? 1 meter.
Yeah, 1 meter. AC is usually fixed 1 meter.
The answer is 12.
No, you've done your math wrongly. Check and see.
Yeah, what's that? 40 over 60, basically 40 over 60.
That's your R. R is L1 and L2 times LS. Put in your value. S is 30.
40 over
L1 is
60 times
40.
30 lah. Yeah.
100 minus 40 is 60. Cancel that.
Yeah.
This is 2. So it's 20 cm. 20 ohm. Sorry.
Yeah, that's what I said lah.
Oh, you said 20. Sorry, I thought you said 12.
Yeah, 30 over 60 times 40 lah. That's what I said.
Okay, okay. I heard wrongly. Okay, let's go and solve your problem under checkpoint before we go to focus. I send you already the next batch of notes. Next topic,
Chapter 5.
chapter 5 or chapter 16. Okay, checkpoint 15.4. Have you done that?
Checkpoint 15.4.
This one?
Then
Can do.
no, not yet do this one yet.
How so terrible one. Teach you already,
No,
must
I'm
do
still
your
studying
more.
the thing. I don't understand.
You understand in class already, then go back when it's fresh, do it. Then you force it in. You don't do it, you're going to lose out anyway. You have to do it now. If not, you're wasting your time to tuition, wasting your money.
Okay, I do. I was doing the revision.
No excuse. This one doesn't take you, this topic by topic, it doesn't take you long time to do it. The most is 10 minutes.
No.
You don't do it, you lose what I thought I teach you already. You understand a topic I teach you, then you go back and do already. If not, every time you come for lesson, you will be lost again. You forget everything.
R equals to 11.1 ohm.
Right? That 100 micro is emitter is given you. RG is 100 ohm. That one. And you want to measure 1 milliampere. You want to find this RS. So you can find this your I minus IG is this current, Kirchhoff's current law. So IS goes to I minus IG. Subtract that. Right? I am using micro. You can change it to ampere if you want to. I'm using micro. So this 100 micro, 1000 micro, sorry, minus 100 is 900 microampere as long as you put a unit there. And PD across galvanometer. One. It's just your I times RG. That's your RG. That's your I. So this one you have to convert it to a consistent unit. So I change this one to micro to SI unit, and RG is 100. Right? So I find the potential difference across here. And it's the same as the potential difference across here. I know the current already. So PD across shunt, this is your shunt. PD across the galvanometer. Okay, so PD is the same. So I just use this PD, it's in volt, put it here. That one is this one. Put it there, change to SI unit, RS, and just cross multiply. 11.1 ohm. Okay, try the next one. Your book is quite good. It reinforces what I teach you. So you can do and remember it.
Go back again. Okay.
Okay, try number 2. Right? Just remember the thing. This one voltmeter, is galvanometer and multiplier. Then write down all your value. What is given?
Hmm.
Then go and calculate.
Yeah.
Current is
So
in this
it's
case.
R equals to 10,000 lah.
Okay, let's see. Right?
Equivalent.
RM is V2 over I. You are told that your current is the same. That's your current. And then you are told that 10 volt full scale. It didn't tell you the galvanometer resistance, so you can take it as 0. So it's 10 here by that. Okay, 10,000, good. You don't need to worry about our galvanometer resistance because it's very, very low usually. You can see that this one is 10,000. Right? This one is less than 1 ohm usually. Okay, this one a bit more challenging. Can be used to measure 10 volt and 3 volt. And you resistance of voltmeter between the 3 volt terminal and negative terminal is 100 ohm, 1000 ohm. What's the resistance between the 10 volt terminal and negative terminal? So in this case, they didn't give you, most likely the resistance of galvanometer is negligible. So you don't need to worry about that.
Thousand ohm.
Let's see. Right? 1000 ohm is given for the multiplier, where this is 3 volt. Calculate out. Total resistance R is, right? That one is most likely 0. So calculate the current because the current is the same. Right? 3 volt divided by 1000. And after that, the same thing. Okay, we have to change in a while. Right? 10 volt now. And then there's your current. Right? You know this is an emitter, so the current is fixed. It cannot go more than that. So that's the current that you have calculated, right? 3 over 1000. So it's times 1000 here, times 1000 here. Cancel the 1000, you get that. So it's 3.3 kilo ohm. Okay. Anything? Anything not clear?
Okay.
Okay. Well, I think I will stop here unless you got any question to ask. Then we'll go to focus.
Okay.
You haven't done it, you better do it now. So take your 5 minutes break.
Teacher, just one request.
Yeah.
You won't tell my mom, right?
I will tell your mom.
Ah.
You don't do your homework, I will tell your mom. because you are wasting your money.
Last teacher, I do homework or not, just don't tell, please.
I give you one more phase. If you don't do your homework, I will tell because you are wasting your parents' money. And I can be assured,
Okay.
I can assure you, you will fail. You don't do something about it. That's why I keep on scolding
Yes,
you.
sir.
I don't allow you to not doing your homework. You come here, you waste your time, and then you go back, you waste your time. Most likely, you are on your smartphone again. So that is your choice. You don't do your work, I will tell your mother again. I
Yes,
give you
sir. Okay,
one more chance.
I
Next
get the
week.
warning, sir.
So today is 2 hours.
Yeah. Okay.
Okay,
Okay.
take your 5 minutes break.
Okay. Sir.
Yeah.
Just say if I wanted to have an half an hour class possible, right?
Why you want to have an hour class for what?
No. I mean, one time you told that like any of the day, like can have half an hour class, right?
Not
Remember that
class.
one?
You want to ask question, you just ask. We will answer you.
Yeah.
As long as it's
Yeah.
not
I mean, I mean that one lah, sir.
as long as it's a short duration, it's okay.
Yeah, that one lah. Just still got right.
Yeah.
Okay. Thank you, sir.